Imagine you're going for a run, and then suddenly, bam! You've fallen. Looks like you got pretty scraped up there. Let's take a closer look at that wound. Uh-oh, you've got an infection. Little animals called bacteria are invading your wound and attacking you. It looks like the bacteria are throwing a rave. We're not completely out of luck though. We've got antibiotics, chemicals capable of killing bacteria or stopping their growth. These chemicals can be life-saving and can stop an infection in its tracks. However, some bacteria can survive this chemical assault. These bacteria are antibiotic resistant. But just how common is antibiotic resistance? And how do these bacteria survive certain death?
Well, let's wind things back and see how antibiotics were discovered. In 1928, Alexander Fleming was the first to discover the antibiotic penicillin after noticing that a fungus had killed the surrounding bacteria on one of his old plates of bacterial colonies. This method of extracting and isolating antibacterial products found in nature revolutionized the field of medicine and became the primary approach to discovering other antibiotics. Some of these naturally derived drugs will directly attack and kill bacteria, such as those that break down its protective cell wall and make the targeted microbe burst. Other drugs can block the bacteria from making important proteins and nutrients and stop them from multiplying. These antibiotics have helped humans fight against fatal diseases in the past, but the bacteria have started to adapt.
Bacteria that survive these antibiotic onslaughts are called antibiotic resistant. Resistance can happen in a variety of ways. Some bacteria may develop resistance if they can pump drugs out once they get in. They can also make specific proteins that destroy the antibiotic before it can act. Bacteria have previously used these defense mechanisms to survive attacks from other competitors, but are now using them to survive ours. What's worse is that antibiotic resistance can spread from one bacterium to another. The interbacterial spread of antibiotic resistance and general overuse of antibiotics have generated superbugs resistant to a large variety of antibiotics. At this rate, antibiotic-resistant infections are expected to kill 10 million people every year by 2050, and we may return to a time when even a small cut could be dangerous.
It's easy to feel hopeless in the face of such a huge threat. Luckily, some of the world's smartest scientists from many disciplines are on the case. They are looking for new antibiotics everywhere from the soil that we walk on to the drugs that we use to treat other illnesses. After all, the diversity of molecules we don't know about is vast, and even our understanding of the molecules that we don't know about is quite lacking. For example, in order to discover antibiotics from these, scientists have worked with computer scientists to develop an artificial intelligence which can rank and predict antibiotic candidates better than humans can. Scientists are also looking for new ways to fight off these infections, aside from just prescribing antibiotics. They have also been researching substances called adjuvants, which are given in addition to antibiotics to enhance the infected person's ability to fight back against an infecting pathogen. Additionally, viruses that only kill bacteria have been touted as a future platform for precise targeting of mean antibiotic-resistant microbes. Scientists are also actively working on vaccines to prevent infections in the first place, though this is less common. And the problem in general with developing all of these great ideas is a lack of a profit and incentive model in a marketplace. Antibiotics are short-term medicines and do not generate as much profit as longer-term medications. So there's very little incentive for the pharmaceutical industries to shunt money to develop new ones.
While diseases and illness is scary, not all bacteria are bad. The human body alone harbors a complex and dynamic population of microorganisms that help to improve our quality of life.
However, we should still stay vigilant. Antibiotic resistance is quickly becoming one of the world's greatest challenges. However, armed with all of our strongest tools and all of our brightest minds, there is no challenge that we can't overcome.